Hi guys, so today we're going to be talking about independence in probability. Before we get into that, I just want to look at part A of the do now with you. If I set up part A for you, you guys should be able to handle B through D, but I do want to set up part A for you. So notice that we have a two-way table here. We have student who has asthma, student who does not have asthma, no household member smokes, at least one household member smokes. So if you think about what that means in terms of just variables, if we said that this was a household member who smokes, let's say this would be our S, so that means someone who doesn't smoke, this would be our not S, and then someone who has asthma would be our A, and then someone who doesn't have asthma would be our not A. I just think it's easier to think about it as single variables instead of the whole category, if you will. So part A says, what is the probability that a randomly selected student who has asthma lives in a house with at least one person who smokes? So what that's actually saying is, what's the probability that at least one household member smokes given that the student selected has asthma? So that's the same thing as the probability of S given A. And remember that when we're calculating the probability of S given A, what that really means is that I want the probability of S and A over the probability of A. Okay, so the probability of S intersect A or S and A over the probability of A. So the probability of S and A, remember I find my S, I find my A, and the probability that both of those things are happening is 113 over the probability of A, which is the total of a student having asthma, which is 182. So 113 over 182, this is going to be about 0.621. Okay. So since I've set that up for you, you should be able to calculate the rest on your own. Part B says, what is the probability that a randomly selected student has asthma? So this is asking for the probability of A. Part C says, what is the probability that a randomly selected student who lives in a house with at least one smoker has asthma? So now this is asking for the probability of asthma given a smoker in the house. And then part D says, what is the probability that a randomly selected student lives in a house with no smokers? So this would be the probability of not S. Okay, so first thing I want you guys to do for classwork is calculate B through D here, okay? And then we're going to get into independence. So two events are independent if knowing that one event has occurred does not change the probability that the other event has occurred. So we briefly spoke about independence on either day 1 or day 2 of doing probability. So for example, I don't know, if I roll a dice and flip a coin, those two events would be independent, okay? The number that I roll on a dice has nothing to do with whether I flip a heads or a tails, so one does not affect the other, and therefore those two events would be independent, okay? So essentially the formula that you're going to be considering when you're testing for independence is you want to ask yourself, does the probability of A given B equal the probability of A? If yes, the events A and B are independent of one another, okay? You could also do it in the reverse. You could say, does the probability of B given A equal the probability of B? So you could also do it this way. Either way you do it. But one thing that you'll notice is whatever value is coming first is the value that you want to know if it's equal to. So does the probability of A given B equal the probability of A? Does the probability of B given A equal the probability of B? So whatever value is coming first in your given probability should be what you're testing if the probability is equal to, okay? So This first question says, using the information from the do now, determine if having asthma and living in a house with at least one smoker are independent. So considering that you guys will have completed the do now, we are able to do these. And if you haven't yet, then you're getting a head start. So anyways, determine if having asthma and living in a house with at least one smoker are independent. So essentially what we're asking is the probability of A given S equal to the probability of A? So this is what we want to test, okay? So the probability of A given S, which is what you will have or hopefully should have already calculated in part C, is that we're calculating the probability of having asthma and having at least one person who smokes in your house over the probability of having at least one person that smokes in your house, okay? So the probability of A and S is 113 over the probability that somebody is a smoker or has a family member in the house who smokes. The total number of people is 395. And I want to know, is that equal to the probability of A? The probability of A is 182 out of the total number of people who got surveyed, 937. So this is what we're testing. And what we end up getting is 0.286 is not equal to 0.194. Since those two things are not equal, that means that these two events are not independent. Okay. If we were testing it the other way, you do not have to do both ways, but some people may have set it up differently. So the other way you could set it up is the probability of S given A. I want to know, is that equal to the probability of S? Okay. So now the probability of S given A means the probability of S and A over the probability of A. So the probability of S and A, we've said, is 113. The probability of A is 182, and I want to know, is that equal to the probability of S? Well, the total number in the S column is 395 over the total number of people being surveyed is 937. I want to know, are these two things equal? And we end up getting 0.621 is not equal to 0.421. And again, these are not independent. And both of these obviously should match up. If you get not independent going this way, you should also get not independent going this way. It does not matter which way you do it. Both ways are valid. So that is not an issue. You could either calculate the probability of A given S and want to know, is that equal to the probability of A? Remember that I said the first letter that comes in your given statement should be what you're trying to test if it's equal to. So probability of A given S, is that equal to the probability of A? Or you could do, is the probability of S given A equal to the probability of S? Either way, you should get the same answer. In this case, that is not independent. Number one here says, a credit card company states that 42% of its customers are classified as long-term cardholders, 35% pay their bills in full each month, and 23% are long-term cardholders who also pay their bills in full each month. Let the event that a randomly selected customer is a long-term cardholder be L, and the event that a randomly selected customer pays his bills in full each month be F. Are L and F independent? Okay. So essentially what I want to know is the probability of L given F equal to the probability of L? Okay. You could also do, I'm not going to actually calculate it, but you could also say, is the probability of F given L equal to the probability of F? So these are the two different ways that you can set it up. I'm going to do it this way. You can do it this way as well. It does not matter. I'm just going to do it this way. Okay. But in order to do that, I need to kind of create a two-way table here and see what's going on. So Not a great table, but oh well. So we have F, not F, and our total. We have L, not L, and our total. So they tell us that 42% of its customers are classified as long-term cardholders. So long-term cardholders is L, and 42% of those people would be the total number of people who are long-term card members. And remember, we're going out of 1,000 here. So if I multiply 0.42 by 1,000, this is going to be 420. Okay. And then 35% pay their bills in full each month. So that is my F column. And the total number of people who pay their bills in full each month is 35%, or 350. Okay. And then it says that 23 are long-term cardholders who also pay their bills in full each month. So that would be L and F, which is going to be here. 23% would be 230. And this is all the information I need to fill everything else in. Okay. So 350 minus 230, this is going to be 120. 1,000 minus 350, this is going to be 650. 1,000 minus 420, this is going to be 580. 580 minus 120, this is going to be 460, and 420 minus 230, this is going to be 190. Okay. So now, if I'm trying to calculate the probability of L given F, and I want to know, is that equal to the probability of L? Remember that this really means the probability of L intersect F over the probability of F. Is that equal to the probability of L? Okay, so the probability of L and F, well, here's L, here's F. The probability of both of those things happening is 230. Over the probability of F, here's F, my total here is 350. And now, is that equal to the probability of L? Well, the probability of L, the total number of L is 420 over the total, which is 1,000. And this gives us 0.657 is not equal to 0.420. And this means that the events are not independent. Okay. If you were to set it up this way, you would notice that you also get something that is not independent. Like I said, it's not necessary to do both ways, just one. Okay. And then I'm going to do one more with you guys. I'm going to do number 2 with you guys. And then you guys are going to finish 3 and 4. So you can just put your do now and then number 3 and 4 into the classwork submission. There is no actual homework assignment for this lesson. So you'll notice that I'm only going to have a classwork submission assignment. So you'll just put the do now and then number 3 and 4 into that. Okay. So when an avocado is selected at random from those delivered to a food store, the probability that it is ripe is 0.12, the probability that it is bruised is 0.054, and the probability that it is ripe and bruised is 0.019. Rounding your answers to the nearest thousandth where necessary, find the probability that an avocado randomly selected from those delivered to the store are ripe and bruised independent, which is actually very weird wording now that I'm reading that out loud, but that's besides the point. Okay, so are ripe and bruised independent? Okay, so is the probability that an avocado is bruised given that it's ripe equal to the probability that it's bruised? Is essentially what I'm testing. Okay, remember that you could say, is the probability of ripe given bruised equal to the probability of ripe? You could also do it this way. Does not matter which way you do it. I'm just going to do it this way. Okay. Again, I need to set up my table here, figure out what's going on. So we have bruised, not bruised, total, ripe, not ripe, total. So the probability that it is ripe is 0.12. Remember, again, we're working out of 1,000 here, okay? So the probability that it is ripe is 0.12. So ripe would be here. 0.12 times 1,000 is 120. The probability that it is bruised is 0.054. So bruised is here. The probability that it's bruised is the total. 0.054 times 1,000 is 54. And then the probability that it is ripe and bruised is 0.019. So this would be 19. Okay. So that means that this would be 35. This would be 946, 880, 845, and 101. Okay. So remember that the probability of bruised given ripe means the probability of bruised and ripe over the probability of ripe. Is that equal to the probability of it being bruised? Okay, so the probability of B and R is here, which is 19, over the probability of it being ripe, which is 120. Is that equal to the probability of it being bruised? Well, that is 54 out of a total of 1,000. And this is going to give us 0.158. Again, in this case, is not equal to 0.054. And this means that these events are not independent. Okay. Okay, so like I said, I want you guys to do 3 and 4 on your own. So what you'll be uploading to the classwork submission is the do now parts B, C, D, and then numbers 3 and 4. Please feel free to send me an email if you have any questions, and I will see you, quote unquote, tomorrow.